All
Hello.
right, well, then we'll work it out together and make sure everybody agrees. Um,
Definitely.
okay, let's see. Um, it's the same thing, as our preparation. So the quiz is exactly the same,
Yeah.
except number one just asks, did you actually participate in this lesson's group meeting? So that's
And
a
I
yes.
got I got my Excel working now.
Oh, that's good.
Oh, good.
No, nobody was could figure it out, and I don't know what they did, but now it's working, so that's good.
Good. I'm so glad. Yeah. Yeah, because I had a similar problem, and I mean, it stinks to know what you're doing mathematically, but the computer isn't working with you.
Yeah.
But, okay. All right, so question 2. Given a 90% confidence interval of 45 to 105 for mean heart rate, which of the following is the best interpretation of this confidence interval?
Okay.
Okay, I put A, we are 90% confident that the true mean heart rate is between 45 and 105.
Yeah, that's what I'd go with.
Okay.
That's what I
Yeah.
have, but I seem to always, whenever they ask a question like this, I seem to always get it wrong. So I'm glad I marked what you guys marked.
Well, that was in the notes, and I could tell it was going to be important. So it says here, when we interpreted a confidence interval, we say we are 95. In this case, it was a 95% confident that the true mean is between the given interval, 2.37 in this case, and 3.71 was the one that they given. But so that,
Okay.
yeah, matched. So.
And you never state that it's like a percentage chance.
Right. Percent chance, yeah.
That's
Okay.
always the one thing it's never when you're using confidence.
Yeah, he said it's either 0 or 1. It either is there, isn't. Okay. All right. So number 3, researchers decided to construct a confidence interval to determine if the difference of means is significant. To determine whether the confidence interval would be reliable, they created QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? Okay. So confidence interval, the requirements, like I looked this up, and it actually has 3. It says that it was drawn, the SRS was drawn, or a simple random sample drawn from a population. X bar is normally distributed, and sigma is assumed to be known. They didn't really give us those options, so I went with what I thought was best. B, yes, the distribution of the mean of each sample is normal since the data have been determined to be normal. What do you guys think?
That's what I put, because I do think it's random. It's a simple random
Right.
sample, because the researchers randomly
Right.
selected. It doesn't really say if the mean is known or not, but
Right, if the standard deviation is known or not. But I think that we find it. I mean, in a lot of these, we found it, right? We found a sample standard deviation, or and I think that. So I think this is sufficient. It's the problem is it's definitely not the others, right?
Yeah.
I mean,
Yeah.
so it's got
yeah.
It is large enough, and it does seem
Right.
random.
Yeah. Okay, so number 4. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? I put confidence interval for the difference of means using independent samples.
Independent samples. Huh?
What do you guys think? I mean, it can't be matched pairs because we don't have the same amount in each group. And group 1 doesn't really determine group 2, is what I thought. What do you guys think?
I did put dependent samples first, but now I see that they're not dependent on each other.
Yeah. Okay.
Because I was thinking comparing one stimuli to another stimuli, but no, it's comparing the different females and different males.
Yeah.
Okay.
Yeah, but that has thrown me more than anything else, actually, in this last chapter, is being able to tell whether it's dependent or independent. But for the most part, from what I've seen, if it's dependent, it is matched up as far as pairs go. So you have about the same amount in each group.
Yeah.
Maybe that's kind of cheating, but okay, number 5. A researcher is interested in estimating savings account balance of customers of a large bank. She obtains the savings account balance of a random sample of 30 customers. 95% confidence interval for the mean savings account balance of bank customers is found to be that. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? We can get a smaller margin of error by increasing the sample size. So I said obtain the balances of 90 bank customers rather than 30.
Right.
What did you guys?
Yeah, that's what I put.
Okay. Somebody else want to read for a few?
Factory makes propeller drive shafts for ships. The quality assurance engineer at the factory needs to estimate the true mean length of the shafts. He randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 100 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculated 95% confidence interval for the true mean length of the shafts.
I got number A, letter A.
I did too. Anybody have any questions on how you get that?
Well, isn't 95 going to be 2 standard deviations?
It is.
So it's going to be something that's about 4 millimeters away from 1,000. Am I thinking that correct?
No, not exactly. So remember, to calculate your confidence interval, Annie, you're going to have x bar minus your z-score times sigma over the square root of n, and then x bar plus your z-score times sigma over n. Your z-score is going to be where the 95% confidence interval comes in, so it's 1.96 that you would use.
Okay.
And then sigma over square root of n in this case is just 1, so it's going to be 1,000 minus 1.96, comma 1,000 plus minus 1.96.
Okay. I guess I was looking at it too simply.
Yeah, I almost did that myself at first. Okay, number 7.
To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weight of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean and standard deviation equals 0.01 grams. How large should n be so that 95% confidence interval has a margin of error of plus or minus 0.0001?
I got C.
Yeah, 38,416, Bernice?
Yeah, that one.
Yeah, and so you're going to use your sample size formula, which is n equals z times sigma over m quantity squared.
Yeah.
Make sure you have all those formulas, guys, on your little cheat sheet. Sample size formula, confidence interval formula, and the margin of error formula.
Yeah, I got to go write all these down because
Yeah.
I don't have any of these handy. They're all spread out in all the different reviews and all the different homework assignments.
Yeah. Okay, number 8.
The mean area of the several thousand apartments in a new development is advertised to be 1,250 square feet. Tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate Nolan hypothesis, alternative hypotheses, HO and HA for review are
A.
Yeah,
Yeah.
less than.
Equals and less than.
Right. Okay.
So in a statistical test of hypotheses, we say the data are statistically significant at the level of significance if
The p-value is larger than alpha.
The p-value is less than alpha, right?
hold on, let me-
Yeah. D.
Yeah.
Did I get that backwards?
Yeah, if the p-value is less than alpha, then we reject H sub O. So I would say that means the data are statistically significant.
Otherwise, they don't matter as much.
So, yeah, right. Otherwise, status quo is what we go with.
Okay.
Kind of reverse, yeah. All right. Group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size of 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer this question?
Yes, it is enough that the data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal.
Yeah.
That's what I would say.
Okay.
Yeah.
That's another one. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has what?
Committed a type 1 error.
Yeah. False
She
positive.
rejected the null hypothesis when the null hypothesis was true.
Yeah, that's like a false positive, isn't it?
Yeah, I don't know if that's what's the problem. Yeah, probably.
Either a false negative, I'm not sure. I don't remember. Anyway, alright. If the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? It goes up, doesn't it?
Yep, by reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
Yeah. What goes up must come down.
Yes,
Right?
usually.
Yeah, sometimes. Right. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams and a known standard deviation of 0.17. Brand advertises that the mean nicotine content of cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of X bar equals 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, we test the hypothesis, which is 1.5 or greater than 1.53 altogether. At the 5% level of significance, you conclude that you should
Reject H sub O.
Yeah.
I'm trying to think about what I did there. Okay, so I found a z-score because we had all the information we needed to find it. We have sigma. And then just looked at using the z-score app, looked at the area under the curve. Just on the right side, though, and it was 0.0388. So let me just make sure. That doesn't mean negative, but measures on a random sample. This evidence of the mean nicotine content is actually higher than advertised. So I looked at, mu greater than 1.5, so just on the right side. And P does give us a value of 0.0388. So I said we would reject H sub O.
Yeah.
Is that okay?
Right with me.
Everybody sounds like they're not quite sure, maybe. Bernice?
Yeah, I had it the failed to reject, but now, I probably did the calculation wrong.
Should we do them together? I mean, it doesn't hurt. Annie, had you gotten to that one yet or no?
No, I hadn't gotten that far.
Well, let's do it together and make sure everybody is on this together. Okay, so Z is equal to X bar minus mu over sigma divided by the square root of n. That's how we find a Z-score in this case, because we have n. So X bar is 1.53 and mu is 1.5, right?
Yes.
And so we're going to divide that by sigma 0.17 divided by the square root of 100 because that was our sample size.
Yeah.
Okay? So somebody tell me what you get.
Okay, let me do it. $1.513?
I got,
No.
I got 1.7647.
Okay, let me redo it. I know, I'm always off.
Well, I don't know for sure. I can't find my scientific calculator right now. But that's what I got when I calculated the first time. My son thinks it's like a phone you can text on. Gets it out and plays with it.
Okay.
Mm. Does anybody have it yet? Or did anybody get what Bernice got, or did anybody get what I got?
Hold on.
Mm. Yeah, that's what I got again when I did it again. Where's Annie and Drew? Are you guys alive?
I'm here. I wanted to check it again myself.
Oh yeah, sorry. I got 1.764705.
Okay. So then in your Z-score app, if you plug that in just on the and look at the area under the curve on the right side, I got 0.0388. Will someone do that though and just check?
Yes.
Besides me, make sure.
Yeah, 0.0388.
Okay, great. So then that's small enough that we would reject.
Okay. Thank you.
Yep.
Yeah.
Okay. All right. Number 14. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? Okay, I put independent samples t-test.
Yeah, that's what I would think.
Okay, I mean, it could be a paired sample t-test, but the way they worded it made me think it's not. Because it says you're going to look at those means to see if they are different rather than look at the difference of the means. So that's
Yeah.
what okay.
Yeah, that's what I feel.
All right, number 15. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? It's dependent sampling because group 1 does determine group 2. If you select a brother so as to compare his academic achievement to a sister, you must include the sister in your study.
Yes.
Okay.
Yeah. Kind of like that husband and wife question.
Right.
So it was independent sampling?
Sorry?
What did you say for that one?
Number 15?
Yeah.
That it's dependent sampling because if you select a brother so as to compare his academic achievement to his sister, then you have to include the sister in your study.
Oh.
Okay, number 16. Soil scientists collected random samples from a field and measured the dissolved organic carbon level of each sample. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Open the data file dissolved organic carbon. Use this information to answer 16 and 17. Okay, of the 4 types of confidence intervals listed below, which one is appropriate for this situation? The confidence interval for the mean when sigma is unknown.
Yeah.
Everybody okay with that?
Mm-hmm.
Okay, if you haven't calculated the confidence interval, go ahead and do that, and let's just make sure our answers are the same on number 17.
I did, and I got the D1 11.168 and 15.217.
That's what I got too, Bernice. So I'm thinking that's probably right then. Okay, okay then. All the girls are downstairs just as usual.
No. You use the one sample t-test for this, right?
Yes.
No, Mama, do a news story, not about those kind of.
I have to step up for a second, guys.
Okay. Anna, you gonna go ahead and calculate it, make sure?
Yes. Okay. So yeah, I got the 11.168 and 15.217.
Okay, perfect. Okay, a random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. We want to know if there's a difference in mean listing prices between Hummers for sale in Los Angeles and Hummers for sale in New York. Create a 95% confidence interval for the true difference of mean listing prices between the 2 cities. Open the data file Hummers, LA, and New York. Use this information to answer question 18 and 19. Okay, I am happy to have you open this one up too. Look at it, okay? Number 18, I said that of the 4 types of confidence intervals listed below, which one is appropriate for this situation? A confidence interval for the difference of means using independent samples. Okay, and the reason why I did that, I think, is because there was a different amount of Hummers in LA than in New York, but also Group 1 didn't necessarily determine Group 2, although one could argue that it does. So I'm open to your thoughts there.
There are so many numbers on the spreadsheet. We're doing the listing prices.
Yes, we're just looking at listing prices, and if I remember correctly, there are more in one of the groups than there are in the other. So you couldn't really, match them up.
I'm like trying to figure out how they're doing the spreadsheet because the New York is so far down the list.
There we go.
Yeah.
Whoa, yeah.
So it's not a paired sample, right? It's just the 2 sample?
Right. Or at least that's what I think. Yeah, honey.
You have to put Becca an A in her.
I can't.
I mean, next year.
Next year she'll be in full day at first grade.
But next time I put as an AM or PM, like if someone comes to Utah and there's someone in kindergarten, put them in PM.
Okay.
More because there was an assembly this morning and Becca won first place, so she
Okay, I got negative 423 and 54717.
got to put carnival food.
Okay,
on
sorry.
her school.
My daughter's talking to me. Hold on one sec.
Sorry, forgot to put carnival food on her school.
Well, she still gets stuff. Okay, so you got which one?
Negative 423 and 5417.
That's what I got too. Okay, Bernice, are you back with us yet? Okay, I'm guessing that's a no. All right. Okay, number 20. Annie, will you read that one?
Yes, I will.
Thank you.
Many studies have suggested that there's a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups. The rats were selected at random from the 3 groups: a controlled no jumping, a low jump group, the jump height was 30 centimeters, and a high jump group of 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats was measured. The rats were selected at random from the 3 groups. Researchers would like to determine if the mean levels of bone density are different between the 3 different groups of rats listed above. Use 0.05 level of significance and use the data file exercise bone density.
Okay. What is the correct hypothesis test? Because we have more than 2 means, it's going to be an ANOVA.
Oh, yeah.
Right.
That's
Okay.
simple.
And I would love for you guys to go ahead and calculate these statistics. For 21, I got 7.978. And that seems so high, but it did match one of the answers, so. Yeah. And Annie, I wanted to ask you, the cars one that we just did, it didn't match up, right? There wasn't the same number in LA as there was in New York. Was I right about that?
Let me glance real quick.
Okay.
Huh?
You need to get to bed, okay?
Yeah, there's more in the first group.
Okay, then I feel pretty confident we did it right.
But I'm scared.
Why? I'm right here.
Because you're not checking, Happy.
I'll check on you. We're almost done. We'll be done in a few minutes, and I'll check on you. Okay?
Okay, for the test statistic, I got
What? Spiders live in this planet. You wonder what?
7.978.
Okay, that's what I got too.
Me too.
Excellent.
P-value 0.00189.
Right. That would be rounded to 0.002.
Okay, yeah.
Okay. So then on 23, there is sufficient evidence to conclude that the bone density of at least one of the groups is different from the bone density of at least one of the other groups. Yeah?
Yeah.
Okay, that's B. Okay.
Have fun. Yet another data file. Okay.
This is the last one, though.
That-
So I'll let you open it up and this is one we actually did in our homework already, so it's pretty, yeah, you've seen it before, but
Okay.
pressures of supply and demand act directly on the prices for an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with a ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance, and then again 14 days in advance. Perform a hypothesis test to determine if there is a difference in the cost of the non-stop flights when tickets are purchased 14 days in advance, and then again, 90 days in advance, and then again 14 days in advance. I think I'm rereading lines now, sorry. Compare 90 days in advance. Use the significance level of alpha equals 0.10. Open the data file, direct flight cost, use this information to answer the questions. Okay, it is a dependent samples test because we're looking at the same flight.
Yes.
The test statistic I got was 1.685, so see if that's what you guys got.
That is what I have.
Okay, great. And then the p-value then is 0.096?
Yes.
Okay. So because we're looking at an alpha at 0.10, there is sufficient evidence to conclude that there is a difference in cost of tickets purchased 14 days in advance compared to 90 days in advance. Yes?
Yes.
All right, guys. Did Bernice join us back yet? Oh my gosh, she's not even on here. Let me try and invite her again.
I got 100%.
I was going to say I'm going to submit it. But, good job, Annie.
Of course. Hopefully we can get Bernice back on here.
This is what I had trouble with before.
Well, I have it written down actually on my paper, the answers as well, so it should
Awesome.
I should be able to help. So I'll keep up. I'm going to end our broadcast, I think, but I'll keep up my video. But okay, well, good luck, everybody.
Yes, definitely. Thanks. Good luck to you.
Yep, thank you. And we're on for Thursday night still?
Mhm.
Okay, we'll see you then. Have a good night.
All right.